In this video, I will be introducing the basic properties of sets. So let's start with an example. We're going to consider the set of integers between -6 and 11 that are multiples of 5. So first, remember that the integers are the numbers. It's an infinite list of numbers, but -3, -2, -1, 0, 1, 2, and the list continues. Okay, so those are the integers and multiples of 5. So it seems like the smallest one would be -5, and 0, 5, and 10. So we can write this set using something called roster notation. And that means I'm just going to list the elements of the set between curly braces. So the smallest member of this set is -5. And then we have 0, 5, and then 10, because remember we have to stop at 11. And I close the curly brace. So this is roster notation. We can also use something called set builder notation to write this set down. Again, I'm going to start with the curly brace, and the curly brace means the set of all x such that x is an element of the integers. X is between -6 and 11, and finally, x is a multiple of 5. And then I'm just going to close the curly brace. Okay, so that's roster notation and set builder notation. So something I want to define is something called cardinality. So in this case, the cardinality of a finite set is just the number of elements in the set. So here we have 1, 2, 3, 4 elements in the set. So the cardinality of this set is just going to be 4. Any set that also has 4 elements is said to be equivalent to my set. So anytime two sets have the same cardinality, they are said to be equivalent. And we can use the following notation. So this set is equivalent, for example, to the set A, B, C, D, because this set also has a cardinality of 4. If two sets have exactly the same elements, we say that they are equal sets. So -5, 0, 5, 10 is equal to the set 0, 10, 5, and -5. So those are equal sets. One last definition I want to mention is this idea of a well-defined set. So a set is well-defined if it is easy for us to tell if a number or an object is an element of the set or is not an element of the set. So for example, the set we just worked with was a well-defined set. But an example of a set that's not well-defined is the set of all states. Like let's say in the United States, such that the state is large. So this is not a well-defined set because large is subjective, it's vague. So in that sense, it's not easy to tell whether or not a state would be in this set. So this example is not well-defined.